Hello everyone, I'm Mr. McBrien. This is TEJ3M, Introduction to Turing. Why are we studying Turing? Well, there's a few good reasons. The syntax is pretty simple. It has a good interactive programming medium. It contains OOTs which are pretty much what we want to focus on for the future. Has excellent communication to the programmer during debugging, and it'll support multiple operating systems. So the downside of using Turing, it is not going to be precisely a model for real-world programming. So the language introduces concepts which then would have to be modified slightly if we want to have C+ or Java coding. So we use these general concepts, and those general concepts will apply to any modern programming language as you move forward if you decide to do coding in the real world. So the programming environment. It's a set of tools for the programmer so we can write, compile, test, and debug programs. The first component of that is simply an editor. We can enter programs here, but we do have other tools as well. So we'll develop the programs in the integrated developing environment, the IDE. It has not just the editor, but a compiler, an execution window, and a debugging tool. When we compile the program, well, the translator converts the Turing code into something that the operating system understands. But before it does that, it looks for errors that are going to cause the program to fail if we do compile it. And that process may look simple on the screen, but in fact it's a pretty complicated and elaborate process. Having said that, it detects things like syntax errors. It does not detect errors in the logic. So you can have a program go through the compile process, no problem, that won't do anything like what we hope it'll do. And in fact, we have to get used to that concept. And so, yes, we go through the verification process, but we will also very regularly have to go through a debugging process as well. So, as good a place as any to begin talking about programming is in terms of inputs and outputs. Inputs, well, pretty much any program ever has some kind of interaction with its environment. If it didn't, it wouldn't be very interesting. Pretty much any program has to accept inputs. And those inputs may come from users, for example, through text from a keyboard. They may come from the mouse. They may simply open files. Or devices may provide them with inputs. The simple programs we're going to write in TEJ3M, quite often we're going to accept inputs from the keyboard. As we get more elaborate, that'll change. Okay, in terms of outputs, of course the most common output is to a computer screen. But in some cases we'll print. In other cases we'll have audio output going to speakers. We will look at outputting to output files. And we'll look at other devices, and really that's the focus of TEJ3M, the other devices aspect. And the interesting question there is other devices, how? And we'll get there. Okay, so there's two ways to run a Turing program. And most commonly, we're going to run the program from the IDE. When we're doing development, that's usually going to be the way we'll work. And essentially all we're doing is testing debug versions. And we can make edits very quickly, get feedback about the changes we make in the code. Now, one thing worth noting is that these programs that we write won't run on computers unless those computers have the IDE installed. And so when we want a permanent version of the program, we'll compile it to work on other computers without the IDE. We'll create an exe file. So today, we'll work in the IDE. We'll take a look at it, and we'll create the classic program today in that IDE and make as many modifications as we can find time for. So what I'd like you to do is just open up the IDE and input some code. The classic thing is putting the words "Hello World" onto the screen, communicating with the user for the first time. And you may have noticed there was a lot more than a simple line communicating to the user there. There were a lot more characters on the screen. And it's good for us to, before we create our first program, make a comment about commenting. We want to not just learn how to code in Turing, but we want to learn good programming habits. And a good place to start, of course, is at the beginning. So we have to acknowledge that code is often around for a very, very long time. It's very common to have code around for months. It's very common to have it around for years. And it's not uncommon to have code exist for decades and still be live in the sense that that code is being edited and updated. In my career in software, I had a number of different developers on the same products. And coders would come and go. It's not uncommon at all. And the program has to live on. It's really important for coders to be able to understand what was done in the past. But if you have a memory like mine, you have to acknowledge that you're going to forget some of the things you did pretty quickly. So it's critical that we insert comments in our code that can provide a kind of roadmap for the people that come afterwards, whether it's us 2 years later or whether it's someone who's hired to replace us when we've gone on to become President of the United States. And every instance where you will have code marked and evaluated, there will be marks for doing a good job of doing commenting. How do we do that? Well, there's two simple tools for that. We can use the %sign to tell Turing to ignore a given line when compiling, or we can use the /* command to ignore all text until that comment is closed. Now, the nice thing about the IDE is it automatically turns the color of all of our comments to green so that we can not just draw our eyes towards comments when we're looking for them, but also see that a given set of text is not a command, but in fact a roadmap. And so if we go back to the code that I put on the screen a few minutes ago, we can see that the majority of the text on the screen was the date that I did the coding, the author of the code, the title of the program, and then a description of the program. And so I'd encourage you to follow this model. Put a title at the top, put the author in, put the date that it was coded, and describe every major aspect of the program. And if you do this, you'll get full marks for commenting when your code is evaluated. So you can go ahead and write a similar program to the one I just did. And then once you've got that running on the screen, once you've compiled it successfully, try experimenting with it. try using a plus sign to output two strings and see what happens. Try using standard mathematical operators in order to do calculations, and you can combine those calculations with output to the screen. So you can mess around with those things, try doing some experiments, see what works, see what doesn't, and pretty quickly I think you'll get a feel for some of the things that you can do. And don't forget to take some notes. On that. Now, if you've got additional time, you can always check the documentation and start playing with things like fonts and colors, backgrounds, all these kinds of things. Feel free to mess around with those things as well to use your time effectively. So in my case, I've got a new set of code where I've put 2 lines as output to the user, and then put some mathematics in as well. Okay, so go ahead and mess around and create your programs, do some compilations and things, and we can start doing some more elaborate things tomorrow. In summary, the Turing IDE is a modern programming interface that incorporates an editor, a compiler, a debugging tool, and an execution window. And today we've learned one of the ways that Turing communicates with the user. Don't forget to post your code to today's assignment. We'll be doing that all the way through this course so that I can monitor your progress. Thank you for your time and have a great day.